Hey guys, today we're going to talk about an equation for the height of a projectile. So first we're going to talk about what a projectile is, and then we'll talk about a fun little formula we can use to calculate different heights of projectiles. So a projectile is like an object in free fall, like maybe it's been thrown up in the air, and the only thing acting on it would be gravity. So once it goes up, it's in free fall, and the only thing acting on it is gravity, so eventually it's going to come back down. Now it turns out the height of a projectile kind of acts in the way of a parabola. It acts like in a quadratic function here, so it's a nonlinear relationship. Clearly when you throw a ball up, it's not going to have a linear relationship. It would just keep going, but gravity brings it back down. And its path will resemble that of a parabola. And at any point we can figure out what the height is of the projectile, and we have a nice formula for it. So I'm going to use h of t, so it's going to be the height as a function of time, so we can find out the height after any given number of seconds. And the formula, we're going to use this one, is negative 16t squared plus v sub o t. This subscript just means velocity, like the original velocity. We're going to talk about that. So it's just a subscript. It's the velocity at a certain point, t, and then plus h with that sub o down here. So I'm going to explain each part of this. So let's start off with the easy part. The t's are going to stand for time. So t represents the time here. So if we know the time, we can substitute in the time that we have. That's nice and easy, and it's a function of time. So if we want to know the height after 3 seconds, we would put a 3 in for the t's, calculate out, and we'd find the height after 3 seconds. This h sub o here, the reason the subscript's there, it's because it's not just height, it's the height initially. So it's the initial height, the height when time is 0. So this is going to be like your starting height here. So it's not just the height, it's the starting height, it's what you're initially at. So that's why we have that subscript to differentiate between the two. And this v sub o right here, this is going to be the, I'm going to write it, the vertical velocity initially. So whenever you throw a ball or anything up, it initially has some velocity going up because you threw it up. And that's going to go right here. So if you throw a ball up and it's going 10 feet per second, then you're going to have a 10 here. And that's all that's telling us. So if we're given information, we can plug it into this formula. Now there are some other things we can talk about. I'll talk about this negative 16 in a second, where that comes from. But just so you know, this side is all about finding out a height at any given point in time. So like if I want to know the height after 2 seconds, that means I'm inputting the time of 2. So I would input a 2 in for all the t's and calculate out what my height is going to be at 2 seconds. So this could be any height here. It's just a matter of what height do you want to find after how many seconds. So that's why we have the h of t. This negative 16, this is actually 1/2 of acceleration, but in this case acceleration is gravity. So gravity, if you don't know, goes at 32 feet per second. In this whole formula, we're going to be using the units of feet and seconds. So the height will be in feet, and the time will be in seconds. So 32 feet per second is how fast gravity pulls you down. So 1/2 of that would be 16. Since gravity is pulling you down, it's going to be negative. If we were working in meters per second, it would be a negative 4.9 if it was meters per second. So if you see a negative 4.9 there, it just means your units have been changed to meters per second. For this video, we'll stick with the negative 16, so we'll keep everything in feet. So this is all the info we need to know about the formula, and we're going to start applying it. We'll do a couple of problems together using both the formula and what we know about quadratics and parabolas, and see if we can figure some things out. So go ahead and write all this down. We'll use all these pieces. So our first question says, Brian throws a discus at the school track meet. The initial height of the discus is 5 feet, and the initial velocity is 38 feet per second. Part A says write an equation to represent the height for any given number of seconds. So we want to find out its height after any given number of seconds. And notice that we're in the units of feet, so we're going to have the negative t squared plus. We have an initial vertical velocity here of 38 feet per second, so that's that initial velocity. And we're going to multiply that by the time. And its initial height, meaning it was when it was thrown, is 5 feet. So we're going to have a plus 5 here at the end. So if we want to calculate any height, we can substitute any number of time. Or if we want to figure out how long it'll take to get to a certain height, we can substitute in the height. So this would be the answer to part A. That's our formula with everything substituted in the right spot. Now the next question says, after how many seconds will the discus hit the ground? So if you think about the height, when we hit the ground, that would be like having a height of 0. We're on the ground. So we can go ahead and substitute that in. And now we just have a quadratic to solve. So I would try to get a positive leading coefficient here. So I'm going to multiply everything by -1. So it becomes positive. Then this will become a negative. Then this will become a negative. Now we can go ahead and try to factor. When we factor this, let's go ahead. Notice that we can't get a leading coefficient of 1, so we're going to have to multiply your A and C, and you get -80, which means you're going to break this middle term up, or you're going to find factors of -38, factors of -80 that add up to -38, sorry. So what multiplies to be -80 and adds up to -38? I would get -40 times +2. That would get you -80. Or you add them, you get -38. Then you get -38, and that's going to break this middle term up. So you're going to have, let's see here, let's do a -40t in the front, and actually I'll do +2t in the front, and -40t on the back, and we'll have 16t squared still. So then when you use grouping, you're going to factor out a 2t, and you'll be left with 8t plus 1. Here you're going to factor out, in order to get this, you're going to have to factor out a -5, and you'll end up with 8t plus 1, and grouping will get you 2t minus 5 times 8t plus 1 equals 0. So if we take this down here in green, which are out of space, so I'm going to go up here, and we are to solve both. The first one, you could have 2t minus 5 equals 0, in which case t would equal 5/2, or you can have 8t plus 1 equals 0, in which case you're going to have t is equal to -1/8. So t could be either 5/2, -1/8. If you're thinking about time, this is a solution to the quadratic, but it doesn't make sense for our problem, so we're going to throw that answer out. So our time would be 2.5 seconds. So after 2.5 seconds, the discus that Brian threw will hit the ground. It takes that long for it to go back down to the ground. And just like that, the problem is done. So let's go on to our second one before you try some of these on your own to erase all this great work. So we have Juliana, and she is throwing a softball upward from a 506 tall building. The ball's height in feet after t seconds is given, so we're given an equation here, is given by -16t squared plus 48t plus 506. There's that initial height. And the ball lands on a balcony that is 218 feet above the ground. So if we look at this formula, we know we're going to be in the feet per second that I talked about earlier. We have the initial height, and we know the initial vertical velocity was 48 feet per second. Now our first question says, how many seconds was the ball in the air? So for this, we need to figure out where the ball is landing. And the ball is landing at on a balcony that's 218 feet. So our final height is 218. That's where we land. We want to know how many seconds it takes to get there. So we're going to go ahead and substitute in 218 for the final height. That's where we land. We want to know how many seconds it takes to get there. Should be a plus sign here. So all we need to do now is solve the quadratic. In order to do this, I would get everything to the same side. Negative 16t squared plus 48t. When you go ahead and subtract the 218 from both sides, we should end up with plus 288. And now we can go ahead and try to factor, or actually I'm just going to divide this whole side, and we'll see if 16 works. I know 16 goes into both of these two, but does it go into 288? It does go into 288, so I'm going to divide both sides by negative 16, which will end up with a positive t squared. Since we're dividing by a negative, we're going to end up with a negative 3t here. And when we divide this by negative 16, we're going to end up with a negative 18. And now we can try to solve. So what can we do to solve for t? Well, let's try factoring. If factoring doesn't work, we can fall onto the quadratic formula. But this is set up really nicely for factoring. So when we factor, we have a negative in the end, so we're going to have a plus and a minus. And we should end up with plus 3 minus 6. So that means t could either be negative 3 or 6. And if we're thinking about the question, how much time does it take or how many seconds was the ball in the air? You're not going to be in the air for negative 3 seconds, so we'll throw that answer out. So the ball was in the air for 6 seconds before it hit that second balcony. And just like that, we are done with part A. Now part B, and the work is going away. Part B says, what is the maximum height of the ball? So, Juliana's standing up here. She throws a ball, and it lands on a balcony. Here's your ground. A balcony that's like over here. Here's your balcony. And we want to know what the maximum height of the ball is. Like I said earlier, projectiles take the motion of a parabola. That's the path they're going to take. So if we're looking for the maximum height of the ball, well, that's going to be the maximum value of the parabola. So think of this just as a normal parabola opening downward. The max value, well, that's going to be the vertex of the parabola. So the path the ball takes, the vertex would be a max here because it's opening downward. So let's go back to our original function. H equals negative 16 squared plus 48t plus 506. So we're going to go back to this, and if we want to find the max height of the ball, well, first thing we should do is find the axis of symmetry. That's how we're going to find the vertex. So the axis of symmetry is the opposite of b over 2a, so negative 16 becomes negative 32, and instead of x, I'm going to put t, because instead of x's, we have t's here. And if we simplify negative 48 over negative 32, we get 3 halves. They're both divisible by 16, which is 1.5. So our vertex, or the max, is going to have a x, or actually in this case t, coordinate of 1.5. And what that actually means for the problem is it's going to take 1.5 seconds for the ball to hit its max height. So after 1.5 seconds, the ball will have reached its maximum height. And now we can calculate out what that height is by using the original function. The height is going to be negative 16 times. We're going to put in that 1.5 because we know when we have a height of, or a time of 1.5, that's when we've reached the max height. So if we go ahead and calculate all of this out, we're going to end up with our height being, and I've calculated it already, will be 542 feet. So that means the vertex of this parabola would be, after 1.5 seconds, we have a max height of 542 feet. So the maximum height is right here, 542 feet. So there are a couple more problems in the slides that you're looking through. I want you to go ahead and try those. Along with the slides, the answers are posted, and I'll put pictures up of my work for them if you're having trouble. If you're having a lot of trouble understanding, you can always reach out to me with an email. But go ahead and try some of these on your own. Have a good day, guys.